want you to go and take the derivative of that first very problem right there, very top. It's the derivative with respect to, this is the derivative. This means take the derivative of x squared plus 1, x, that squared, minus 2x. Remember how you're going to do that?
Why would I go 1 over it? I mean, under it.
You would
Not a big deal. Just do it.
just put in x plus delta x for that.
No. I would foil that together again so that I don't have to deal with the whole, do it the formal definition way.
Emerson, stop moving my chair. You're so annoying.
We got that for posterity. That's big detour to the land of proofs.
No.
Careful what you wish for. Right now, Pecorino's on the list, but you may take it from her. Whoop, whoop. I want to take derivative of two functions together. Now, you said earlier I have to use the limit. Given that these are open-ended, I'm definitely going to use the limit, right? I have no special... Who asked me to take the limit for? Who was saying limit? You don't want to tell me. Wait, is that your brother? No, not brother. Sorry, cousin. Second removed. Something I don't know about. What? Mr. Resendez, can you do this problem? You said take the limit. Who said take the limit last time? Like 2 seconds ago. So, never mind. I'm all done with you people. All right. Somebody in this classroom said, if I don't know what to do, I need to take the limit. So I'm going to go ahead, yes, limit. We're going to do limit here because we have absolutely no idea how to do this. We don't have the hope. So I'm going to do limit. I got my formal definition. So that'd be f of x plus delta x times g of x plus delta x, right? Minus f of x, g of x, all over delta x. Do you agree with that first opening salvo of fun? Okay, now I'm going to do something completely weird that seems unfair, but it's a legal move. And I'm looking at a piece of paper because it is a weird move. It's not a move you would instinctively know to do. I'm going to, this is the same thing as before, right? But I'm going to randomly add the following. I'm going to subtract the following. I'm going to put a minus f of x plus delta x times g of x. Just casually do that. Now, if I casually do that, what must I immediately do after subtracting that? Wait, what? If I put a random subtracted thing in there, what must I immediately follow with?
What?
Added. Same exact thing, right? So plus f of x plus delta x g of x. And then I've still got this thing hanging off the back. F of x, g of x. With me? All over delta x.
Why would you do that?
Because it makes the problem work. Now, is it a legal step? Yes. Would you come out, would you be sitting at the desk and go, well, I think I should just put in a, I don't know how you come up with that on your, frankly. Okay. But it does something very interesting, doesn't it? Anybody see what it does is interesting? It doesn't cancel it out. No, it doesn't cancel it out. But if I group this, I can get something very interesting going on here. I can get the limit as delta x approaches 0. I can pull out this from the first two terms, correct? From this term and this term, and I get f of x plus delta x times, what would I leave behind? G of x plus delta x minus g of x with me, right? Because I pulled it out of these two, I pulled that out of the front end. And then over here I've got plus, and then I've got, I can pull a g of x out of both of these, right? So I'm going to pull out a g of x, and then I'm going to go, what I have left over is f of x plus delta x minus f of x. Still all over g of, oh, there should be parentheses around this one, over delta x. Now I'm pausing here for a moment. Okay, so what I did is I put this thing in that I added and subtracted, so that's a legal move. Then I factored by grouping, right? I pulled these two out. Pull this out of this one and this one, and what is left over I multiplied, so I can distribute it back in if I wanted to. right? Do the same thing here. I notice I have g of x. I pull g of x out in front. Now left behind these two pieces right here. What do you so far? Now here's where something incredibly catastrophic happens. What is g of x plus delta x minus g of delta x over delta x? What is this? What is this piece right here? Well, except that if I plug that in, I get 0 over 0. This is the formal definition of g of x, isn't it? This is taking the derivative of g of x, isn't it? So this right here becomes g prime of x. Agreed? What is this piece here? That's f prime of x. What is that? Just plain old g of x. And what is this as we approach 0? F of x. And so the derivative with respect to x of f of x times g of x is f of x times the derivative of g of x plus g of x times the derivative of f of x. So if I have two things multiplied together, I can take the derivative by simply writing the first one times the derivative of the second one, plus the second one times the derivative of the first one. That's how I can resolve the derivative. Now, does that really work? Let's take a look backwards. Here was my function I started with, right? And since we could do this, we know this is the answer, correct? But could I do this using my new rule? Derivative with respect to x of x squared plus 1, x squared minus 2x equals. So, the first one times the derivative of the second one. What's the derivative of the second one? Ms. Pecorino, I didn't ask you any questions. Holy man, how do you get away with that? It's almost criminal. What's the derivative of the second part?
2x minus 2.
2x minus 2, love it, plus. Now the second one times the derivative of the first one. What's the derivative of the first one? 2x. Now I'm going to simplify. What should I get if I did this? If this works? We should have got what we did by doing it by foiling, right? So let's do this. So I got 2x to the third plus 2x minus 2x squared minus 2 plus 2x to the third minus 4x squared. Simplifying, I got 4x to the third for these two. I got minus 6x squared. I got a plus 2x and a minus 2. Any chance that's what it's written up there? Yes. That's happened before. Like, okay, well, math happened bad in the middle. So that's the way you can do it. Okay? Does that make sense? All right. If that makes sense, what I'd like you to do is I would like you to go down to number 2, and I'd like you to go ahead and use this definition, this product rule. We're going to call it the product rule. And use a product rule on problem number 2. Take a stab at it. Yes, sir.